Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you did on this problem. I'm gonna solve it live right about now. Cool. 901 online stock span. Given a class stock spanner which collects daily price quotes for some stock and returns the span of that stock price for the current day. The span of a stock price today is defined by the maximum number of consecutive days for which the price of the stock was less than or equal to today's price. For example, the price of a stock over the next 7 days was just some numbers. The stock span will be 1112146. Okay, so I read the problem. So let me think about what that actually means. Um, okay, let's say we got 100. You got 180. We got one. Why is 70? We got 2. We return maximum number of consecutive days for which the price of the stock was less than or equal to today's day. So 70 returns 2 because, well, we saw 60. Do we just keep on collecting, or is that it? Uh, okay. 75 is bigger than 70s, 60, 70, and 60. So, yeah, I mean, okay. So this is actually, I mean, I just wanted to make sure, but, oh, hey, thanks for the follow, Aaron Chow. Um, yeah, I mean, I think this is there are a couple of ways you could do it. I think you could do it with uh, a binary search tree or something like that. I think the binary index tree is what I'm going to, or how I'm going to solve this. Some of it is because I still need to practice a little bit, but you could actually probably do this with well, if you're lazy, and I'm tempted to be, you can actually do this in C++ using like a map class and then just call lower bounds a lot. Uh, but I think I'm going to practice for the purpose of me needing practice a binary index tree. And the thing that comes up is that price is equal to 100,000. So that means you can fit it into a binary index tree because at most you're going to need 2 times that space, which is just 200,000 ints and stuff like that, right? Okay, cool. Let me try to. So, okay. How do I set up a binary index tree? I don't remember. Uh, or Fenwick tree, if you want to call it that. I have pre-written code. Let me see if I could remember. Um, hmm. Okay, but the general concept is okay. We first set up. Let's call them counts. Is equal to 0 times some max n and max times 2, say, for a reason that and then max n is 10 to the 5th. I always add a little bit padding just for off by 1 error, or potential 1 by 1s, but probably not necessary in this case. But okay. So now we have, let's add some helper functions, which is, I think, increment, it's what it's called, which is, let's say some x. We can actually, usually you also put in a parameter for the increment, for how many numbers you want to add, but in this case it's not necessary because you're always returning by 1, or yeah, adding by 1. So I forget there's like a cute way of doing it, but so index is equal to what's it, x? Why do I have so many windows open? Okay, and then while index is less than max n. I just say line of counts. Or index is equal to what do we call it? Index plus 1, I think. I've written this both ways. There are a couple of ways you can do this increment, but I don't know. I have to be consistent about it at some point, to be honest. But and that's pretty much it. And then now there's the get the number, which is I forget what I call it, but I just maybe it's called sum or count sum. No, sum is a keyword though. And that is I read it over. Sleepy. Yeah. Yeah, I think I've been talking. I don't know. I've been fighting a little bit off some sickness over the week, not the weekend. But my voice is still a little bit gone. Hopefully, it's okay. And then this is, I guess, I like to set it up this way. Index. And then return s. Okay. And then now all we have to do then is for every price that comes in, we do a sub. Well, I guess we have to store the store the number that is smaller, and then we do an increment on the price, and then we just return the number. Hopefully that works. Have a good night. Okay, well that's not great, but oh, I have to include itself. Okay, that's not bad actually. So then that's actually even easier because now we could do the increment. All it means is that we have to increment first, but I misread it. I just didn't think about it. So that should be good enough. Okay, except for this one case. Why is that case wrong? 2 to 60. Is it strictly less than? Oh, it's consecutive. I missed the consecutive part. That is a little bit unfortunate. Okay, so it is not binary index tree then. Huh. So let me think about it for a second. Solved the one problem though. I mean, it's still good that I got practice on binary index tree. But that's not going to be it. Okay. I think I just misunderstood the problem. So that means, so basically what you want to do is you want to look at the first index that's bigger than the current index. Is that right? Okay. How would I do that? Still probably like something. My intuition is some sort of tree-ish thing. Basically, was for 60, yeah. I'm just trying to think about. I mean, so you can definitely put this in a tree-like thing, and that'll be okay. But I'm just trying to think about. Yeah. The like implementation wise was this the easiest way to implement it? I guess map actually in C++ is still okay because it does the tree for you. and you just get the no, because you want to get the index that is the closest index that is bigger than the current number. Okay. How would I do that then? There'll be at most all these cores, but that means you can't do anything. You need to do stuff that's like at most log n. Okay, so 70, right? Totally missed the consecutive part. Starting from today, going back. Okay. Okay, so from 75, we want to. I mean, you want to go to 80, but in a parallel kind of input, like if 80 is before 100, you still want to go. You want to go to 100, not 80, right? So you can wait to that sort of thing, but you can build on it. So it's just now. I was gonna say maybe there is some like dynamic programming thing, but then in this case that falls apart a little bit because even though it goes down, the next number goes up. So I think there is some like stack-y stuff on it. I think there is some like stack implementation where yeah, there's probably gonna be some stack stuff where you keep on pushing and then here you pop and then yeah, and then you keep on going and here you pop 1, 2, 3 to get. Yeah, I think there's some kind of stack. Okay, let me implement it then. Let's call it steps. I guess we don't really need this anymore. Okay, so when we get a number coming in, what happens? Okay, so that stack. If the length is 0, then let's just append price, return 1. Else, we actually want price and also a number so that we can maybe merge it later. And then now, else, while self.stack, if the last number is bigger than the price, then self.stack that append price 1, return 1. Right? Well, that's not a while, but we actually want maybe with the opposite of that, where while self.stack minus 1 is equal to, then so the price is going up. Let's say in this case, you want to actually merge these two nodes. So then let's just say so. So let's just call it last price. Last count is equal to self.stack.pop. And then self.stack.append or push. Let's just do the current price now, and then last count plus 1. Is this a 1? Because you probably want to like an accumulator. Okay, fine. So count is equal to 1 maybe. course, here we're gonna add this, and until we get here. Okay, fine. Okay, so we actually don't push this quite yet. We want to do it at the end. Well, and stack, and the length of the stack remains bigger than 0. Let's put this in the front for pre. Okay. And then now we can just do this. And then this is already true by default. So then now we can return C. Maybe I don't do C plus 1 is C, right? Okay. Oh. This might be greater than you go to, but cool. I got it right on the first try, which always feel good. Well, kind of the first try. I ended up spending 16 minutes on this, even though I misread the problem, which happens. I just thought it was the number of days previous that is smaller than the current day. But yeah, but this is I mean, it's a stack problem. I want to say I felt like I've done similar problems to this before, but it's also been a while, so I don't know if that's actually true. I mean, in terms of interviewing, I mean, I've definitely done something similar in competitive programming. So using a stack, this is O of n time and O of n space. The O of n space comes from that each price coming in, each incoming price will always take up one we'll take up one space at most. So and given n of those, that's O of n. In time, technically is O of n overall and O of 1 amortized. But given this while loop, in theory, it can pop off a lot. But each element can only be popped once. Therefore, you get the O of n running time thing and O of 1 amortized for the time. Yeah, hey Sunny Me, how you doing? Yeah, did I not? Sorry, I just did it backwards from how I usually say it because this one has some average. But let me know if you want me to clarify a little bit. But yeah, but overall, this is O of n because at least on the both time and space on the time side is because each element gets popped by this only once. So each element will only be popped once. So that's only going to be part of the while loop once. So that's why it's O of n for time. In a stack problem, I feel like it's a fair game though. Though from my sense is that it's not as I don't know. I feel like I don't see as much stack problems unless it's some sort of like parsing type problem, like parentheses matching and stuff like that. I haven't seen these kind of like stack problems where you keep track as much, except for actually, I guess I've seen one about max stack before. But I think it's still worth a good practice, especially if you haven't done it in a while. So definitely recommend it because stack is, comes up from time to time.